Right. So first, let's see how applying abstraction a little bit can take us a little bit too far, right, into meaningless. Right. We looks like we are at a particular level of abstraction where each one of these variables have meaningful names. We know what they mean. Right. We have some expectations of how they behave. So let's apply abstraction. We have been selling you the idea that abstraction is a good idea, right? That to try always to make it as general as possible, right? But we already familiar with the idea that perhaps some classes are way too general, right? That's why we call them abstract classes, right? That makes no sense to instantiate them. Yes, that you have to have some more concrete derivations of that class to have some meaningful usefulness for it, right? And there's even higher level of abstraction where you have interfaces where you just declare the signatures, but you don't even provide an implementation. Yes, so we already know that there are different levels of abstractions of how to describe ideas. So let's apply it here to a model. Let's see. We're always thinking, well, how far into the future should I consider this going, right? Should I try and be as flexible as possible? We certainly did that when we started with just tic-tac-toe, right? And then we moved over to just connect 4 and then perhaps connect n. Yes, we were always trying to make it more and more general. And so let's try and go even further. Perhaps we want to be very flexible and say, well, I don't want to represent users, right? The players. Just with an integer, right? And what if I want to represent that player's first name, last name, and how many times they've won, and all sorts of information about that player, right? And I might perhaps be better off by representing him with a class player, perhaps. Yes, or we can go even further. I don't want to commit right now to any particular implementation of that player. I'm going to just leave it into some amorphous object, right, that is going to represent a player. And then I'll leave it to anyone in the future to decide later to commit on how they want to represent the player. Very, very generic. Yes?
If you leave too much out, aren't you basically making whoever implements it just like recode kind of most of it?
That's where we're going. This is where we're going. Right, so we're leaving it up to a future coder to decide what the data structure of this player means, right? And we're just deciding to go all out, as generic as possible, and just leave it object, right? So that's that. Wherever we have a representation of the player, we'll have to replace the with this representation. In this case, object for the turn. Whose turn is it? Oh, it's that player's or that object's turn, right? This is where let's keep going, right? So this is where we were, right? This is what the models we started with, and after our first iteration of applying abstraction, we end up with something like this, right? We have replaced the integers with an object, right? Something that is a little bit too generic, perhaps, but nevertheless, we are delegating that decision to someone in the future. Right, so that they can decide the actual implementation. All right, so let's keep going. Let's go even farther, right? Somebody says, well, why stop at 2D, right? At connect n, and says, well, why not 3D or 4D or leave that undetermined, right? It could be any level of dimensions, right? It could be n dimensions, so that instead of just being a list of lists. Then it would have to be a list of lists, right? Or it could be very indefinite. So why not leave that also undetermined, right? And somebody later on might decide that it's a map, or they can choose to have perhaps a dot on how many elements do they want to pass in to decide. And we'll give it an appropriate name, right? We don't know what the columns might look like. What size, what shape does it take, right, in 4D or 5D or 6D space? So we'll call them hypercolumns, right, and leave that undetermined for somebody else in the future to decide how to capture that. That means that the width, the height, is also becomes somewhat undetermined, right? Because there is no base, there's no height, right? We might need to be able to configure them in some generic format, right? It might have all sorts of different things that need to be configured, not only width and height, right? There could be all sorts of things that need to be configured. So might as well just create an amorphous map of configurations, where I can put whatever I want in there, right? And it'll be indexable by some generic string, right? And I can have any number of configurations in there, including width, height, and whatnot. Yes, and this is for the variables, the immutable variables, right? Which don't maintain any state. That has a final value, only at the configuration time when it's instantiated, and then it doesn't change over time, right? So excellent. So we've made another level of abstraction. So this is where we were just a minute ago, right? With the list of objects, and we had the width and the height, and we've gone a little farther, and just subsumed those. We've abstracted them to a generic set of hypercolumns, and a map that can capture all the different configurations of width, height, and whatnot, right? So let's go even further, right? And say, well, even the goal players, why leave the goal players out there? Those two could be things that be configured, and they can be subsumed into the configuration map, right? Why leave them out? It could be it doesn't have to be necessarily just 2 players. It could be n players, right? And taking turns at different and be connect also is also configurable. We can include them also in the configuration. There's no need to keep track of that as well. And so those are also subsumed into our configuration map. Now there's the status and the turn. Perhaps the state of a 2D game is perhaps a little bit too simplistic when you try to scale this up to something that might be multiple dimensions, right, and have multiple players playing at the same time. So I might need to maintain all sorts of status information about this fairly complex game over time. So I might just put that in a map where I can keep track of the statuses and whatnot, and those are changing properties as the application just plays out, right. And the state changes over time. I would keep them track. The different state would have its own entry point into a map and what the actual value it is. I don't know if it's a numeric data type, of an integer or float. I don't know, right? So I'll just keep it as an object, some amorphous object. So to infinity, and beyond, just might as well put everything in a map, right? Why even have them in a separate hypercolumn in a different map? It could just be a very generic map with some generic string, and I could replace it and retrieve it anytime I want, right? And just call it some generic properties, right? So now I've become somewhat meaningless, right? I could use this for any game, really. It doesn't have to be even Connect 4, right? It could be anything. Any game could be represented as just a set of properties that change over time, right? So perhaps we've gone a little bit too far, right?